Welcome to Kotlin Multiplatform in production. My name is Kevin Galligan. I'm president of a company called TouchLab. And I've been doing Android development since before the G1, so quite some time. TouchLab is a mostly mobile development shop, right? So we started around 2010. We were Android only till about 2016, make apps and Android things. We also do a lot of community stuff, so we run the big Android meetup in New York. We also started Droidcon in North America with Droidcon NYC and a little bit of SF in the early days, which means I chat with a ton of Android developers. My role, although I'm the president, has transitioned in the past year or so into being sort of the crazy research person in the back room just playing around with stuff. So I don't do any client work. I don't do any of that stuff. Mostly it's been multi-platform technology over the last few years, and specifically the last year has been Kotlin Multiplatform exclusively. So hopefully I've got some information that will be useful to all of you if you're considering it. So what is Kotlin Multiplatform? And I start with this because especially native mobile developers, we tend to say anything that's not native is cross-platform and talk about them as if they're a singular concept. And they're absolutely not. And the different tools have different pluses and minuses. And that seems logical, and people get that until you start saying, well, I don't do cross-platform, but. So I'm going to explain why Kotlin Multiplatform is actually a different technology than a lot of the other ones we talk about, right? So I have this definition. I try to make it as dense as possible. Kotlin Multiplatform is an optional, natively integrated open source code sharing platform based on the popular modern language Kotlin, which facilitates non-UI logic availability on many platforms. That's as dense as I can make what I think is important about Kotlin and distinguishes it. So we'll unpack that. Optional sharing, right? You can share a little bit of code, you can share a lot of code, you can go feature by feature, you can do a test in one sprint. You don't have to commit to what we call like a big decision, right? Like you don't have to say, hey, we're gonna do this whole third platform and we're gonna like hire and train these whole things, whole different people, right? And like, I'm gonna call out some other things during this talk, and I apologize in advance if you're super fans, but something like Flutter is a big decision. You have to make a big decision to do that, and that's risky. And when we're talking to developers, it's one conversation. We're talking to management at larger orgs. The conversation about risk is a much more important one, and it's something I think developers have to keep in mind when they're thinking about different technologies to implement, right? So, optional sharing, which is facilitated by native integration. Kotlin is designed to interop with the underlying platform it's on natively. Like there's no third environment, there's no VM, there's no bridge, right? Like if you think about it, on the JVM, obviously Kotlin interacts quite well. JS, not a super expert on that side of it, and I hear it's pretty good. Native, which is the only thing I've been doing for the last year, when you're using native code and talking to Kotlin, the native code in Xcode thinks it's just another native library. It's not in a separate VM or a memory space, it's natively integrated, right? And that's pretty important. Open source, kind of self-explanatory, but you like to be able to see what's going on without getting any surprises. Android, we're used to that. iOS world has not always necessarily been the case. And code sharing. So code sharing, I don't say cross-platform, really, because it's like a ruined term that carries a lot of baggage in people's minds, right? This allows the sharing of logic, and optionally, again, it's very important. It's not trying to be this big single thing that treats native as an exception and you launch a totally separate thing, right? So I think that's important. Popular. Kotlin, I can say, definitely is popular. Like, it has the most growth on GitHub, I guess, and project contributors. Is voted consistently one of the top, most wanted to learn languages. I'm used to speaking in front of much smaller crowds doing J2OBJC talks from prior years. So this was like Droidcon UK, right? And this room's going to be full again too. People are super excited about this, even if they haven't done anything with it, which almost nobody has, but it's coming, I promise. Oh, and the popularity is important because the community and the libraries and the support and really what's going to happen around it. And it's going to be a big deal over the next year or so. Language and tools, obviously, people like the language, but more importantly, JetBrains makes the tools that everyone loves, right? JetBrains is the best shop right now that makes any kind of development tool. So that's important for developer experience, obviously, and it's going to matter for adoption. Modern, and of course the language, I guess, is called modern, and we could get into that discussion. But more than that, the JetBrains is making decisions to have the whole platform keep up with what the best of what's going on out in the other parts of the world, right? So watch the KotlinConf keynote, and Andre talks about a bunch of stuff, but one in particular is scenario concurrency, which is going to come up later in the talk. They're not simply bringing forward our old ideas into the future and on the old problems. They're making sort of tough decisions to have this go on to be a modern framework in the future. Not UI. And when I say not UI, I mean not necessarily UI. People are definitely going to try to build shared UI on top of Kotlin Multiplatform. People are already showing me demos, and good luck to them. But shared UI is difficult, right? Shared UI, I would say, has a history of rough road and often failure. The platforms that you're deploying on don't care about the other competitor platforms. They care about their own UX. So it's very hard to have a lowest common denominator meld of the two. And you either wind up with like an unholy mesh of native components, so Java AWT, or no offense, React Native kind of, or like, you know, Xamarin Forms, or you just throw everything out and try to do something entirely separate, like a Flutter or an HTML5 if you're rendering mobile, Java Swing, that kind of stuff. It's traditionally been hard to build something that people really like. However, shared code is the history of computers, right? Like everything you think of, we got there because we're sharing stuff. You're not hand-rolling everything every time. So if you're talking about which one's likely to be more successful, I don't really get into that who's going to win game, but like that's shared code's always going to beat out shared UI. I love this slide because when I talk about write once, run anywhere, people are always like, ha ha ha, what a failure. Remember when Java tried to do that? Well, yeah, Java UI didn't work out so great in all cases. Java as an example of shared code and a medium of doing that, it would be very hard to put a number on the efficiencies gained over time and what the impact Java's had on the world. So it all depends how you think about it. And many platforms. So, I mean, there's a bunch of stuff, right? You got the JVM, obviously, JS, you got a bunch of native platforms. We got WebAssembly emerging, which is going to be very interesting. And you can deploy to a lot of these platforms with Kotlin Multiplatform. And if they're not ready today, they are very aggressively adding new platforms as they emerge and adopting them. So there's a big future that's going to happen with this. So for all those reasons, if you want a summary slide, high efficiency, low risk, modern language and tools, highly engaged community. This is why I think the Kotlin Multiplatform is going to have a pretty big impact. And I don't get into the, well, what about this versus that? Because it's just kind of a different situation. So, web, other platforms, yada, yada, that's all great. But we're at a mobile conference, and I think most people in here are thinking about this in the terms of how do I share mobile code? And I will tell you from experience, sharing mobile architecture and logic is easy, right? For all their differences, you know, Android and iOS are basically the same under the label. I had to add this slide because I don't think people were getting what I was doing with the soda, okay? But like, yes, Coke and Pepsi are super different, and if you pour them in 2 glasses, now you get the Pepsi challenge. It's much harder to tell. Same thing with mobile. You've got Unixy systems, you've got SQL, you got files, you got threads, you got networking. Under the hood, they're doing a lot of the same stuff in very similar ways. So we're at very early days for Kotlin Multiplatform. So right now it's not like easy to share code necessarily, but if you've been following me for the last few years, I've been doing this J2OBJC thing, which nobody cared about, but it was like super efficient. We got to the point where they released Room, and I got the source jars, and I had Room working on iOS in 90 minutes. And we're like gonna get to that point because it's super trivial to share logic and architecture on mobile. You just trust me, but we'll get there. So where are we at today? It's moving very fast. So if you're watching this on the video, assume most of this is already old anyway, sorry. I've been making guesses over the last few months, and KotlinConf was sort of the big, you know, what's going to happen at KotlinConf, right? So we got 0.93 for native. We got a merging of native and proper Kotlin version numbers, which is good, so they're in lockstep. We got official tooling, which is huge, because before that there was no code completion understanding. So it's so much nicer with code completion. On the downside, we were waiting for multi-threaded coroutines, which we didn't get, which we're still waiting for, which kind of sucks. And the tools existed but weren't exactly stable. So here we are now. Fast forward to today. November 19th, 2018. You've got stable Kotlin Native release, 1.0.1. It's beta, but at least it is in the stable 1.0 state, tied to an official Kotlin, Kotlin 1.3. That is critical because it means stable library dependency deployment, which we haven't had up until very recently. Gradle 4.10, multi-platform deployments. which prior to that, JetBrains was doing 4.7, which if you're an Android developer, you should know the new version of Android Studio will only do 4.10. And it's a long discussion, but we have 4.10 and that's good. And like Jake Ward and Alex Strong figured that out literally a couple weeks ago. And I kind of figured out a hack to make that work on BinTray. So that's that. Summary, things just got way more stable. So if you're going to try to build a library or you're going to try to build a thing and start learning this, now is a very good time because it's much more straightforward. Now we're going to guess what's going to happen in the future. So Q1, and I have pretty good info on what they're doing with the coroutines. It's very hard in native because of state and threading, but we're expecting a Q1. Hopefully January, cross your fingers, right? You can do a single threaded, but it's weird. Anyway, it works, but yada yada. We're going to get stable, much more stable Gradle tools and a lot more tutorials and libraries. Like right now, you really have to understand how to poke under the source and figure things out for yourself. I think you're going to be capable of productive development in production in Q1 as long as you're able to navigate like a new environment that doesn't have a lot of stable docs. Not everybody is really on board with that, right? Q2, this is completely speculative. I don't know. JetBrains need to make something that they can charge a license fee for because unlike most other software vendors, they actually just get paid for a product. We'll see what that looks like. No reactive library until they figure out the coroutines, but then JetBrains is going to build a reactive library. There's several discussions about that. So hopefully then, I think around Q2, you're going to start hearing about major production apps that are actually releasing with this. So if you take a step back, forgetting the details, around Q2 is when this is going to start becoming something you can bring up in a meeting, and it's not going to be like a weird option. It's going to be sort of a mainstream option. I don't know how many people are going to actually be adopting it, but we'll see how it goes. So if you just wanted to know when can you start putting it in your app, March, I guess. I don't know. That's kind of my guess. But if you wanted to start doing this early or really learn about this stuff, you should start pretty soon. And if you wanted to start working on libraries and get involved in open source, you should absolutely start now. Now is like finally a good time to do it. So what is it and how does it basically work? To start with, you're going to have this common module, right? This is common standard lib Kotlin, which means it's going to not have things you're used to having in the JVM. So there's no file, there's no date, there's a whole bunch of stuff that you're used to being able to just reference that isn't there. Common code can be running in all kinds of environments, right? It might be in a world with or without threads, it might be on a phone or a server or an embedded device. So rather than making this big, huge base runtime library with a bunch of abstract methods, JetBrains went very lean and provides you with a mechanism to figure things out. So if you wanted to find out, am I in the main thread, right? There's nothing in Common Kotlin about threads. So what you have to do is this thing called an expect artifact, in this case, a val. And we say, hey, expect main thread, right? And what that means to me, when I call this from the common code, I'm going to get an answer from the platform-specific code that's correct. So on the platform-specific code, you do an actual, right? And to be clear, these wouldn't be in the same file. They'd be in separate files, but they're on the same slide. So just conceptually sort that out. On Android, you're going to check and see if your looper is the looper. On iOS, there's this convenient Boolean that comes in the form of a method. And just to close the circle, if you were doing JavaScript, it would look like that, because you're always in the main thread. Right? During the process of development, if you all have installed the Droidcon app, you're all running a Kotlin Multiplatform app. And during the process of development, like no libraries existed. So anytime I needed something that wasn't provided in Common Kotlin, you just create an expect function and implement it on there. And like this is actually old. Several things are gone now because we've implemented libraries that encapsulate these things. Classes also work, so in this case, there's no date, right, which we discussed. So we have a basic date and a basic date formatter, which is absolutely critical for a conference, unless you don't care when the sessions happen. On Java, you implement it with Java util date. Don't try to digest the whole slide. Some of these things they're gonna fly by. The date format is using simple date format, and there's a similar iOS implementation. You can check out the source if you want to see what that's doing. Other ways to share common code. In a more general sense, you can create an interface and have the platform-specific things implemented. In this case, we actually take on Apple initialization some lambdas that do some things on the native platforms. So, for example, in the Droidcon app, we want to do seed data that's going to come from the local stores. And we have a lambda that's going to provide that data form back as a string. And on Android, we just go to assets and get that data. On iOS, we just open up the bundles and get the data out of there. And that totally works. And it makes it really easy to do certain things that would have been otherwise a lot more difficult. So Back in the common module, of course, it's common. This has to be rendered down to something specific. So you define what platforms you want this to actually be implemented by. And obviously JVM and native in the case of native mobile development. On iOS, that turns into a framework. And if you've never done iOS, it's how you share code between different things, basically. So to Xcode and to Swift and Objective-C, this looks and acts just like any other Objective-C library, which is pretty critically important, right? On the Android side, one thing that's unique about Kotlin Multiplatform is that it's only half of a cross-platform framework, because everything that happens on the Android side is 100% native. There's no like weird stuff. It's like how you would have done it, possibly with a slightly different library, which takes all that side of the risk of using a cross-platform thing and kind of lifts it away, which is nice. Then you do all of your native stuff, and I want to like highlight again how important it is that this is an optional code sharing platform. So your apps can be mostly native and a little bit shared. You can incrementally increase that over time. Again, important to say low risk and low big decisions. So it's very important. That's why we are pushing this and really dig it. So if we want real production to happen real soon or sooner than it would otherwise, the one thing that's super critical and needs to happen soon, which is why I keep pushing it, is libraries, because there's like very few. I'm going to show you all the libraries I'm aware of that you can use in native mobile right now. They're on 2 slides. JetBrains, KTOR, networking library, big deal, you should learn that. Kotlin X coroutines, if you're going to try to use any coroutines, obviously a big deal, you need to understand that. If you aren't using coroutines or reading about them, you should start immediately. Kotlin X IO, which is a low-level IO library, which is coroutines enabled. Thank God that clock's counting down. I was like, oh my God, there's no way I'm going to make it. Sorry, there's a clock up here. I had a moment. Kotlin X serialization, which does essentially JSON and I didn't know what CBOR was, and protocol buffers, very useful. Atomic Foo might be being removed from the slide in the near future because they haven't really updated to native yet, and my new library just completely like gets rid of it for me, so we'll see. From the community, the obvious big one is SQLite. That's going to be the big flagship library that's going out. And I have a fork of SQLite that you can use this thing called NarcDB, which I wrote to do iOS database development. NarcDB is taking the Android open source framework SQLite stack and making that work on iOS. So that's how we've been getting the iOS apps to run in multi-platform. Multi-platform settings, which is like shared preferences, but NS user defaults on iOS. A thing called Stately, which is another library that I wrote, which allows you to manage essentially, it's utility libraries for the differences in state in Kotlin Native, which we'll get to in a minute. OKIO 2, which is published by Square. It's another low-level IO library that's going to take a while before it's really fully multi-platform enabled. And some people are like, isn't that confusing that they have competing libraries? Like, maybe. But what it says to me is when someone says, is Kotlin multi-platform going to be a thing? Like, yeah, absolutely. Jesse Wilson is like pushing out a new OKIO that's going to be multi-platform. I would expect it to be a thing. Timber, sort of. If you don't know what Timber is, it's Jake Wharton's logging library. I have a branch that makes that work on native, so sort of because we don't have an official version. That's like it, right? So if you want to get involved in open source libraries, like now is super the time because you can do something that's going to have a huge impact. Speaking of, life comes at you fast. So as I've been talking to people about NarcDB and saying, hey, I took this SQLite library from Android and we just replicated in iOS, everyone's like, you know, that's just full of a bunch of hacky stuff and that's not what we want. So on the flight home from Droidcon UK, I started working on a separate database library and I like announcing stuff at conferences. So in keeping with that tradition, SQLiter. It's a trim and lightly opinionated SQLite driver, right? The thing is that SQLite C API turns out to be really good and robust. It's meant more for machined clients, so like SQLite will use this. Room, if they ever do start doing sharing cross-platform, would use this. You necessarily might not be calling it, but because you have to know how to clean it up. It's not that hard, but you know, it's not going to fix your problems for you, right? If you're using the Droidcon iOS app today, this has it in it. So it is running, and it's not open source yet, but in the next couple of weeks, we're going to open source that. And if you don't like the name, this one also came up, SQLite, but you're welcome that I didn't settle on that one, because that's terrible. So targets. Native SQLite totally makes sense, because nothing existed, and in fact, I was I rushed to get this out because I didn't want NARC to be the thing and carry forward some bad ideas. Not that the Android, SQLite, Google team did a lot of bad stuff, but it's a decade of old thinking. You had to get rid of it. Native SQL encrypted, that's coming soon, so SQL Cipher encryption extensions, we're going to be doing that. Same API, that should be cool. The big question mark is Android SQLite. And there's been some desire to also give the same treatment. Unfortunately, you can't bind with the NDK to the native SQLite on the phone, so you have to compile and ship a whole different SQLite, which is going to add maybe up to a meg of extra weight. Might be a big deal. Other people seem to think it's going to be a good idea. Smarter people than me seem to want it. We'll see. I don't know. We're going to try it out pretty soon. We have a version working. And then the encrypted version isn't that big of a deal because they also need a special SQLite anyway. I know how you do it. Big questions JS. Fun fact, you can compile SQLite to run in JS. You just can't save anything to the local disk. So we're sort of poking around and seeing if there's some use cases where that makes sense. So when is this happening? Well, there's a pull request for native SQLite to take that new driver. And then literally a couple hours ago, I was chit-chatting with Alec. So I don't even think the CI is done yet on this, but they're going to merge this in. So sometime probably Wednesday, you're going to have a release candidate that you can do SQLite, multi-platform, Android, iOS without any funky branches. So that's where we're at. That's how new all this stuff is. Okay, public service announcement. If you understand anything about native, you need to understand the following. State. Okay? This is the big thing you have to understand, and everyone keeps they're just blowing off what I'm saying, and I'm like, no, you don't get it. It's totally different. There are three ecosystems. There's a JVM, which treats state and threading exactly as Java does today, and there's JS, which does whatever crazy JS stuff they do, right? The native thing is getting that first treatment of standard concurrency, and during the keynote, they were like, hey, we're experimenting with native first. And that means if you're outputting native, you have to understand the implications of what you're doing. You have to understand some rules, okay? Here are the rules for Kotlin native state. And if you were falling asleep, wake up 2 seconds and I'll be done, I promise. Rule 1, live state belongs to one thread at any given time. You can pass ownership of that live state to another thread, but there are very strict rules and it's syntactically cumbersome, I would say, humble opinion. Number 2, you can freeze state and share that state between threads as much as you want. I'll explain frozen in a bit. Okay, you ready for the other 20 rules? There aren't. That's 2 rules, that's it. If you understand that internally and you internalize what those implications mean, you're going to be way further along to understand how Kotlin Native is going to be doing state. But it's not that simple. It's going to take a little while. There are no threading primitives. There's no synchronized. There's no volatile because you're not allowed to manually manage concurrency anymore. That's not entirely true. You can, on iOS, get a lock and still manage it, but it's different. You're not supposed to be doing this. Why do they do this? So the purpose is that with these rules, Kotlin in a runtime level has some hope of ensuring that you're not doing something horrific with your concurrency. And that's the point. And other languages are getting these features, and Kotlin, again, moving forward, is trying to incorporate some of the best features out there in other languages. I think, we're going to have to really think about how to architect code, maybe instead of just sharing data across all these threads, you got to do different things. I don't know, but I think it's good for the long term that Kotlin is focused on having a better ecosystem for the next decade, and that's kind of what's happening here, even though it's painful for now. So JVM and JS, again, watch the KotlinConf keynote. It's really interesting. They're talking about bringing these ideas back into these other platforms. We'll see how that works. They're also talking about doing compile time, which is sort of Rust-like if you know any of that stuff. But for today, it's runtime and native only, and you need to understand it. Short-term pain. So I've been talking about this at many conferences now, many being 3, but many conferences, and after that, everyone pulls me aside and says, I tried it, and it's really painful. Don't you hate how they're doing this too, kind of thing. And I'm like, I did it first. It really sucks. But once you get used to it, for the long term, it's a good payoff. Because if they didn't do it now, we all know how that works. It's never going to happen. We're going to have the same bad ideas going forward. So how does Kotlin know that your state is immutable? Well, it's frozen, but what does that mean, right? And when we started doing frozen, I think people really hate it, but I try to have a more positive spin because you really get used to it. And I just went through this morning with Alec, trying to explain no, this is why you have to do that, right? Frozen is a runtime designation, also known as a flag, that's on your object header. And it tells the runtime that your object and everything that it touches is frozen. It's not simply just immutable or a bunch of vals. To get frozen, you call freeze on an object. The thing that you have to understand is that when you call freeze on something, it's going to recursively freeze everything that it references. So there are definitely implications to that, right? And it's a one-way operation, so there's no unfreeze. You cannot change it once you've frozen it. Like under the hood, it's actually changed structure in some ways, so it's just done. For example, let's take this. We have this variable that's an int, and we're going to send it in a lambda to a background call to increment the thing, right? But since we're going to go to another thread, we freeze the lambda. The lambda itself has to be frozen. That's what the freeze method call there does. But unfortunately, that does this. So now your variable can no longer be changed, and this is obviously going to crash. So it's just one of those little things that's funky, and until you really understand it, it's hard to like do it. And I could explain it all day, but you really just have to start coding and see how that works. It's usually okay if you think about it, right? Like when you're doing data, you shouldn't really be mutating your data through the various functions it's going through so much, right? Like, so if you're getting data from a database, let's say with an RX thing or whatever, when it comes to the next part in your chain, you shouldn't be like changing it. The way you should be doing it is like creating a new object that wraps it and delegates to it and morphs it in that way, right? Like that's best practice. So usually works out. In some cases, it's way more difficult. So global state, global shared caches, things like that. Like if you had a big hash map that you wanted to keep around to do a cache, it's extraordinarily difficult to do in this context, right? Yeah, so we'll see. I think it's a good time to mention again, over time, it's not just going to be adding libraries and making Kotlin Native fit to how you think. I think it's really going to be the community also rethinking best practice. And anybody that's like, I know what's going to happen right now, that's crap. Like it's going to take trial and error. It's going to take more blog posts, more conference talks, and people figuring out the best way to kind of do this stuff. So we'll see. I don't have all the answers, but we'll see. It'll come. I am promised I'm going to have a much better tutorial. I'm committing to sometime in December because there really isn't a good Kotlin Native state tutorial really explaining what frozen means. But we'll see. I'm committing to it. So, or maybe I won't. I don't know. See how it goes. So, passing state. And I mentioned you can pass state, but this is more difficult. I'll very briefly go through this because it's not going to explain all the rules. There's this thing called detach object graph. And on the right side, you see there's a lambda. That's a producer. The producer gives it data totally detached, and it has some hope of detaching it from the rest of the graph. And then on another thread, you can reattach, right? This works. This would fail because the outer context still has can still see that data val. So it gets really syntactically difficult to start doing this stuff. And do not try to ingest this slide, but I have an example code in my open source that shows you how to build a structure to do this. But it's very easy to leak the data that's in there. So when you start accessing it from other threads, if you hold onto a reference and try to detach, it's going to fail, right? And a minor thing, detaching requires you go through the whole object graph to make sure nothing's talking to it. So in that case with the hash map as a cache, if you had 50,000 elements in that hash map, the benefit of a hash map is constant time lookup and insertion. Not anymore, because if you go get something, look at it, and then detach, you're going to have to hit everything in that node. So it's another thing to consider. Summary, detach sounds like something everyone wants to do, and they start doing that. And then eventually you just get to the point where you're like, nah, this is terrible. I rarely use the detach thing and try to share live state because it's just a complete pain in the ass. There's something new that they put into the pull request. It's still an open pull request. And it's a shared mutable binary data. This isn't a Kotlin Native thing. What does that mean? It means a memory block you can change for multiple threads. And it's a totally different state of memory, like frozen, but called shared. So I don't know if this is an experiment. I don't know if they're going to try to now like let you share state, which is essentially getting around all the rules that they were doing before. I asked, I didn't get an answer, which is actually kind of rare. So I don't think they want to talk about this much. But I think it's just very special case because the method that lets you share state is private. You can get around that, but I'm not going to tell you how. You can figure that out later. Anyway, atomics. This is really kind of how you deal with a frozen lifestyle. So Kotlin Native added atomic structures that allow you to mutate state inside of frozen objects in a very sort of restricted way. So there's atomic int and atomic long. So in a frozen object, you can have these and do operations on them. But the real big thing is atomic reference, right? So you can update frozen objects. So if you have a frozen thing, inside there you can have atomic reference, and you can like change what's in the atomic reference. It still has to be frozen, but at least you can mutate that state. It sounds restrictive, but like everything else, I'm like, you get used to it quick. Somebody told me I have Stockholm syndrome. Like, I have to like it, so I learned to like it. But I don't think that's true. Like, I really, like, you get used to it. It's not so bad. So earlier I showed you we passed in lambdas to do some work. But that object you're passing them into is already instantiated and frozen. So what you have to do, I make a data object, I freeze the data object with the lambdas, and then assign that in the atomic reference. So it allows you to update that state that is presumably fully frozen or whatever. Stately, which is the thing I had in there before, which I announced at Droidcon UK, is essentially something that facilitates a lot of that stuff. So there's only the freeze method in Kotlin Native. So this defines a multi-platform version that does nothing on Java. And then it defines multi-platform atomics and some annotations that are from Native that do nothing on Java. The more interesting thing that's a little weird is that I defined a whole bunch of shared collections that are all implemented with atomics. So it's a hash map implemented with atomic references, things like that. Is that hash map anywhere near as performant as a regular hash map? No, it's not even close. But if it's the kind of structure that you need, it's a very useful thing to have. So in your normal app work, I don't think you should be using these shared collections. But if you need to share stuff around with a big service object, it's absolutely super useful. So that's that. I try to find a balance of like technical information versus this is just a conference talk that's an overview. So if you want to get more deep in the weeds, I'm trying to have a well-updated list of stuff that's out there. So go check this out. And we have a bunch of samples and videos and going to be updating things as we go along. So getting back to we need libraries for production to be a thing. Rather than do something else, I'm like, I'm going to show you how to make a library with the new tools in the last few minutes of this talk. So first thing, download IntelliJ EAP. Eventually you can download Android Studio, but right now there's a little bit of, it's just easier. Go get EAP. And in recent versions, they've added these templates, so you can just do new project, and they have all these wonderful new things that come right out of the box. So just go Kotlin Mobile Shared Library, and it gives you this thing with 3 source sets, basically. Common, iOS, JVM. Pretty straightforward, and they have main and test of both, right? A little heads up, until Kotlin 1.3.2, the Android library AAR publishing is a little bit difficult. You can totally do it, but I wouldn't even try to explain it in this talk. So anyway, you get this. They don't, for some reason, include the wrapper, but not Gradle W or the jar. So just go ahead and copy those things in there. I have no idea why. And in the presets, it has JVM and iOS, which totally makes sense, except on the command line, if you have that, you won't see your tests run. So I just made that to a Mac OS X executable, and then when you run build, it'll run your tests. In more complex examples, obviously things get more complex. This is from Stately, so it's not always going to be like that, but for the purposes of this talk, it is. So I always tell people live coding is just a horrible idea. There's like never a reason to try to live code. Don't be a hero. And I was preparing to live code, and then I just said, why? Why don't I take my own advice? So I made a little video, which I'm going to narrate real quick. That way nothing goes wrong. Okay, so what we're building is a library that allows you to see what platform you're currently on. And they have that in the sample library with a name, but we all like emojis, so we're going to add an emoji that gives you an emoji of the platform you're currently on, right? Very useful library. You're all going to love it. So the first thing we do as good developers is we don't even do the implementation. We add the tests. So we're going to add a platform test in the common code, and in the platform test, we're going to have a very JUnit looking like thing, a class, and then a function with a test annotation. And what that's going to do is verify that our platform emoji is equivalent to what we're expecting. So you notice a pretty similar syntax here. Assert equals, and then platform, that thing we just wrote, which is emoji, and then this method, which doesn't exist yet. And then we're going to do an expect method, like we talked about before, in the testing. And the good thing now is these tools all actually work. So it tells you something's wrong. Well, first of all, I forgot to put string as a return. But then when we fix that, then it's still something wrong. So we auto-gen the actual platform implementations with IntelliJ's tools, right? Nice and super easy. And for iOS, we're going to return an apple, right? Super magical. And then on Android, we're going to return a little robot head. So There we go. So now we've got our testing implementation all ready to go. The test should run, and currently it won't compile because we haven't done the platform-specific implementations for emoji. So we go to, what, JVM first? Yeah, and it's red. So we auto-gen the emoji method and essentially do the same thing. And then we're going to do that and then go back and do iOS, probably. There we go. See, if I was live coding this, you know this would take it just wouldn't work. Something would go bad. So we're going to return an emoji, right? And if anybody's paying attention, you'll understand what's about to happen. So we run the tests, and then native build is a little slow right now, so we got some movie magic. Let's see how that goes. And boom! All right, so we go and look at what went wrong. Oh my gosh, such a surprise. Oh yeah, okay, there we go. So we fixed that, and spoiler alert, it's going to do what you would expect it to do. We didn't go through publishing, but that's basically it. Building libraries just got like way, way easier. So I encourage people, if you want to get involved in open source, like go check this out, because now it's like a really good time, because there's really nothing out there. Some suggested ones, like we need a basic, like, hey, let's load some files and manipulate them. Like I made a really basic copy of Java file, IO file, but it's you don't want that. There's no real date support. Somebody did publish a date thing, but there's some controversy because there's no like tables in there. So there's no hope of doing leap seconds and all that kind of stuff. So somebody take a look at the 310 backport and see if you can double backport that into Kotlin. Mocking is going to be real hard, but there's some work going on at that. Reactive library, UI state. I want to talk about like the Mavericks talk earlier. Like a lot of the native community is moving towards sort of a React-like unidirectional state management thing. So I want to see if we can get this in shared code below the UI. Again, shared UI is not my thing, but we'll see how it goes. There's a ton of other stuff. And if you wanted to have an impact in open source, now is a great time. Speaking of getting started. So join a Kotlin Slack. It is still early enough, specifically multi-platform and native. It is still early enough that the JetBrains team will directly answer questions. And there's a bunch of people, it's that early adopter phase of the community, and they're super excited. So people will definitely help you out. Sample apps. So I've been traveling out of pocket for the last few weeks, so I don't know if anything's released in the last 2 weeks, but up until then, there were 2 basic sample apps, and they were both conference apps. One's KotlinConf by JetBrains, and one's Droidcon app by yours truly. I know that I wrote Droidcon app, so when I say you should look at the Droidcon app, everyone's like, of course. But you have to understand, JetBrains is great, but they told me specifically we're not mobile developers. There's no database in their app. It doesn't use a reactive architecture. It doesn't work offline, which is kind of bananas at a conference considering how awesome the Wi-Fi usually is. So I would say look at the Droidcon app. And I am making a commitment to also, I was going to do it before this conference, but I was working on libraries. But as SQL Delight release candidate comes out, we're going to do an overhaul and a re-update of all the libraries. And over the next several months, we're going to try to make this like the sample app. So take a look at it. I mean, give me till like next week to have this initial update. And yeah, we want to make sure that this is like a really good sample of how to build native mobile multi-platform until there's 20 other samples, right? And I didn't realize the color scheme until like today was like almost exactly like the Flutter sample app. I absolutely promise it's not running Flutter. But anyway, if you want to build a library, again, not because I wrote it, but take a look at Stately because it's very simple and it's new. So it has a new Gradle architecture. There hasn't been time for like the Gradle publishing to get all mangled and custom and all that crazy stuff. It's easy to digest. After that, look at SQL Delight. That is a big professional open source framework with a lot of really complex configuration, but it shows you kind of the extent of what you can do with multi-platform meshed into a normal library. If you have any questions, I thought I was going to be out of time, but apparently I do speak faster on stage, so I'm not entirely out of time. However, we're having a office hours at 2 p.m. in Koblenz, which I guess is that way. Come ask me anything. And then there's a cross-platform fireside chat, which is happening right before the party. So you're going to have to make some personal decisions on that. But it'll be, I think, pretty interesting. This is my contact info. I would say follow me on the Twitters. You can email me too if you want. If you're on ASG, I'm on ASG. I'm on the Kotlin Slack. If you have any questions, please feel free to reach out. We're going to release a bunch of stuff over the next few weeks now that we're not traveling and conferencing, so there'll be more tutorials and other stuff. We were aggressively hiring for our first multi-platform hire, and then someone on the team expressed a strong desire to be that hire. So we're less aggressively hiring, but we're interested in talking to people that are interested. So shooting more around January, especially if you're closer to New York. But hey, if you're super into it, let's talk. That is it. Do we have questions? Yes. So I guess to repeat the question, I'm very bad, I don't repeat them. Are you saying, yeah, as these new changes to Kotlin, is it going to break legacy code? And you're talking about the standard concurrency changes to how underlying things run? So I'd watched the keynote. Andre was super light on any sort of details, so they didn't talk about that other than to suggest it'll be in the future. I can't imagine on any possible future that they're just going to suddenly break everyone's threading, right? I think it would have to start as like an optional thing to enable. But what happens down the road, I don't know. I mean, but they definitely made a hard decision on native to not start it that way, So no, I wouldn't expect that if you update to Kotlin 1.5 that suddenly everything breaks, other than how it would normally break. But that kind of stuff.